Welcome, boys, to our practical lesson. Today I am going to show you the tips on how to use a concave mirror and a convex lens. A concave mirror a concave mirror converges. Okay, so rays from distant object, when they fall on this mirror, they will converge somewhere. Where they converge, we can use the screen to show us where convergence has taken place. The distance from the concave mirror, let me put it on a cell holder, the distance from a concave mirror to where the rays have converged is called focal length, symbolized with small f. Okay, so I can focus a distant object like a window. Okay, I can focus a distant object like the window. When rays pass through the window, they'll come to the mirror, and then the mirror will try to make them meet at a particular point. That is focal point. So the focal point will be determined by the help of the white screen. You might be given an object like a pin, okay? An object like a pin. So that pin, when it is far away from the mirror, the image of the pin will be seen at the focal point. So I'll try to use the screen to show us where that point of convergence is. That point is a focal point or principal focus. But the distance between the mirror, the concave mirror, because that is what we are dealing with, and the screen is called focal length, small f. The principal focus is a point, is capital F. So for example, I have the window on this side. Okay, I have the window on this side. Maybe I try to just move this. You see the window on that side. We have the window. Sorry, we have the window. And now we want to come and do the experiment. Once in a while, I must focus so that you get the idea. So I have my meter rule here. I've put the lens, the mirror, at the beginning of the ruler. So what do I want? I want to see if I can focus that window on my screen. So I search from far coming towards the screen. I search from far coming towards the screen. Some people may search from near going away. There is no problem. So you can pick the direction, okay? So you can pick from just next to the screen, you move away from the concave mirror, or from far come towards the screen. So let us try. There, you keep on moving, you will see a very sharp image. Now when you see a sharp image, I want to take the camera so that we see this in the reality, and then I will take it back. So we take the camera. We take the camera near here. Now you can see far. I'm coming near. Want to see if you will see a sharp image. Okay. I want to focus on the experiment. Hope you'll be able to see. maybe this position. Okay, you can see somewhere here. Can see somewhere here. Move, it disappears again, and then you will see a sharp one. You will see a sharp image there. My camera is there. Hope you are seeing this. This very bright part is what I'm trying to focus. So you can see I'm bringing it. It disappears. So you have to be very keen on this. So when that is where it is focused, I cannot show it better. That is where it is focused, and that is the arrangement. You can see this is the concave mirror, and a sharp point is somewhere here. Okay, the sharp point is somewhere here. So I have to get the distance. Which distance? The distance which I'll measure should be from here up to here. And if you can see, maybe I focus on the reading. I'm sure you'll be able to see a few figures there. Okay, you can see a few figures. I want this figure here. So it is roughly 11. It will be roughly 11, if you can see that. That is the arrangement. Okay, so that is how we get the focal length. So my focal length is 11. This is focusing a distant object to the screen. What about if you are given, suppose you are given, you can see that. See now, nice. It is there. You can see. I hope you are able to concentrate here. You can see even when I move it, you can see the sharpness. Okay. Sharpness. So there, you will get a rough figure. Now we go to the second way. Suppose I'm provided with a pin. I'm provided with a pin. With a pin, you can have two methods. These methods are backed by your theory. One theory is that a distant object is brought to focus at the focal point. This time, it is the pin I'll put far. Okay? Now, this pin is being held by a cork. In other words, even if I focus the cork, I will get still the same answer. So which are these two methods? Number one, a distant, I put it very far, a distant object, the rays will come and they will converge at a focal point. A second method that can help you is to try and get the object and image on the same level. That is, when the object is at C, okay, the image is also formed at C. Meaning that we shall get R, small r, and we know that 2f is equal to small r. Therefore, f is equal to r over 2. These are two possible methods when you are given a pin. So let us try and see. I have my distant pin. I want to show the setup. This is the mirror and that is the pin. So what do? I want to move. Keep on moving. Okay, I'll keep on moving until I see the object forms an image. Okay, so let us try and see. For example, I have that now. This is my object here. This is my object, this. So I'm looking for its image using the screen. Okay, try and move. It is somewhere there. If you are, it is somewhere here. I can see the cork. So I may not see the pin, but I will see the cork. And this requires quite some high intensity of light. It cannot be done where there is just some mere light. So according to me, I can see it. It will be difficult to show you, but we will try to use the camera and focus. Okay, try to use the camera and focus and see if you can appreciate there. It is difficult, but somewhere, if you are doing, you will see the cork. It is easier to see the cork. I can see the cork. Can see the cork. I'm trying to get a position where you will be able to see the cork. It's a bit difficult, but as you move, you see the cork. And you make sure you are not blocking the path of rays and looking for them. That is a big mistake students do. They block now. I've blocked the path, and you expect the rays to go to the mirror. So those are sources of error. So what you do, put it aside, slide aside, you can see there. So you put it aside and try to move. Okay, at some point you see the cork. There is a cork somewhere there. If you have good eyes, you will see there is something there. Now once you have that, you focus on this part which is seen. Okay, let us try to get it right. Let us try to get this right. You have here the pin. The rays come to the mirror and then they are converged here. So what was I trying to tell you? You can see a shadow here. This is where you can see the cork has been focused. So roughly you read. Again, you will read. You read. This one is roughly is giving me 14. Okay, it's giving me 14 because of my situation to explain, but you will be thorough when you are doing it. So that is method 1. That means my F is 14. These are experimental results. Now, what is the next one? If I have known my F is truly 14, I can confirm with the second method. What is the second method? If F is 14, it means R is 28. Okay? If it is true, F is 14, then small r is 28. So what do? I bring this cork at 28 mark there. And then I try to see, so the cork, I have shifted it from far to 28 centimeters mark. Okay? It is at 28 centimeters mark. I want to put this screen there and see if I'll see the image. If I will not see the image, then 14 is not accurate figure. So let us move it there. So I can't see the image. That means 14 is not accurate figure. So I can go up by 2 or 1, both sides. 14 plus 1, 15. 14 minus 1, 13. I keep on looking within those ranges. 14 plus 2, 16. 14 minus 2, 12. I keep on looking until I get it. So let us try and see. Now I'm going down and I try to get this. I'm going down and I'm trying to get there. I try to see if I can get the image. I can see nothing. Can see from far there is something here. So I can still go down and see if I can get. It is there, but I want a big. Let us go up 24. It is difficult to show you with a camera, but you can be seeing there is something here. Okay, keep on trying. I hope you are seeing there is something here, and they have to be the same size. Okay, if I put there, it disappears. So it means I have to look at it below 24. If I do that, it appears. It appears. There. So it's roughly there. You can see this is the pin, and if you are keen, you will see there is an inverted image, and they are more or less the same. You can see the level, and this is the level. This gives me around 22, 23. So 22 is small r. 22 is small r. 22 is small r, because the object and the image are on the same level and they are equal in size. So how do I get f? I take r divided by 2. That is 22 divided by 2 is 11, which gives me the same as the previous one using the window. Even if you had 23, you would say 23 divided by 2, which is 11.5. So I can conclude that using my setup, I can conclude that the f, the small f, is 11. Okay, that is the basic way of getting the f for a concave mirror. Okay, that is the basic way of getting f of a concave mirror. I conclude: 1, you have the meter rule, you have the concave mirror. You can focus the distant object like the window using a screen. Then you get the focal point here. You get the focal point. You will see a sharp image on the screen. Then the distance from the mirror to the screen is small f. A second method is when you are provided with a pin. Okay, I can put it far. In other words, you already have a clue from f due to the window. You have a clue. So if my f, small f, was 12, double 12 is 24. Put it maybe at 35 from the mirror. That will be still a distant object, very far, 40. Then you try and search for the image, taking care not to block the path of the ray to the mirror. You take care. So I put it slightly on the side so that the path is clear to the mirror. Okay? Some may want to put it just on top there, but remember this part is not solid, so it cannot fit. You can put it at some reading. Now it is on top of the ruler. Then you search for the image. Where is the image? You keep on searching. Okay? Now, when you do that, you record your figure. The pin at distant, very far away from the mirror, and then you try to focus, get a particular figure. Like I got 14. After getting 14, you confirm. If 14 is the focal length, then capital C will be at 28. Transfer this to 28 and use the screen there and see if you will see the image. If it will not, you can move up or down with respect to 14. I chose down, so I moved it down to 12, and then I tried and to focus to see if I can see the image. Okay, you try and see. So when this pin and this screen are on the same level and you are seeing the image is inverted, the same size object and image, you can see that just by visualizing. Then the distance from the mirror to the screen becomes small r. Okay, it becomes small r. I got 22. That was my small r. The small r divided by 2 gives you small f. And somehow I confirmed what I got from focusing the window with my second result to be 11 or 11.5. That is how you go about it, folks. This is something you can do and get it. Next time, I'll deal with the lens. Bye-bye. See you.